Hello everyone. In this video, steel frame member properties will be explained. Let's display the model in orthogonal mode by hitting the F12 key on the keyboard. The frame member command is located among the steel member category under the Modeling tab. When we wait for a few seconds on this command, a tooltip window that includes information on member properties and usage will appear. You can refer to this tooltip window anytime during the modeling. Now run the command and as seen in the command line, pick two axis intersections for member insertion. As we can easily snap to the nodes of the elements, we can also use smart points to snap to the points calculated along the members. Besides, by holding down the Control key on the keyboard, you can easily snap to the desired point on the structural members. Let's add a stability member by picking a truss node point. We can see the label of the frame member under the General tab on the Frame Properties window. All the frame members are automatically numbered by assigning the prefix of F. We can find the member quickly using this number. We can set the frame type using the list located under the label field. General, vertical brace, horizontal brace, purlin, and girt types can be assigned to the frame members. We can set the frame to be a general member if we do not want to assign any type. Also, if we use the frame members to model a custom truss, we can use general selection. Apart from that, although the vertical and horizontal brace types are identically the same for analysis, they must be assigned properly to frame members for the IntelliConnect command to work correctly in ProtaSteel. We can also assign purlin and girt types to frame members as necessary. Let's continue with selecting the steel profile of this frame member. Under the Database tab, we can see different profile catalogs that are prepared for different country practices. Here, a profile assignment can be made easily. Let's select an IPE 300 profile. We can also select built-up steel or cold-form steel profiles for the conventional steel purlins and girts. Let's select an IPE 300 profile. On the right-hand side of the Section Manager window, we can see the material grades selection fields. Again, we can see a catalog of material grades prepared according to different standards. If we want to define a new material grade, we can click on the Add button and make a new material definition. Let's select the S275 grade and close the window by clicking the OK button. Section Reference Anchor Point enables us to fix the alignment of the member so we can change the assigned profile without shifting the member edge. Below the section anchor point, we can see the angle field. You can manually enter section angle values such as 20 degrees or minus 20 degrees. You can quickly adjust the local axis angle by clicking the Pick Element to adjust section angle button and pick a member on the screen. For example, we can align the frame member with the inclination of the truss top chord using this command. Just below the section angle field, we can see the frame end conditions. We can set the frame end conditions by checking or unchecking the box for the relevant internal force. Checking the box will release the corresponding internal force. By using the button on the right-hand side, we can quickly assign the end conditions. When we switch to the 3D tab, we can see the fields where we can fine-tune analytical and physical offsets. Analytical offsets enable us to shift the endpoints of the frame member on the analytical axis. Here, an important point is that the analytical offset of the frame member should not go out of the plane and lose connectivity with connecting members. Otherwise, some mechanism formations may occur due to the elements not being connected properly to each other. During modeling, the analytical position of the frame is already automatically created by snapping to points on the screen, so it is not usually required to play with analytical offsets. We can also set the analytical wire reference point for the frame member. In general, brace members are aligned along their centroidal axis, so the middle center option can be used. If we need to change the section alignment, we can do so by using the alignment options. Now, let's assign a physical offset to the member in addition to section alignment. We can assign out-of-plane or in-plane offsets. For example, to offset the member by 15 cm out of plane, just enter 15.0 cm in the out-of-plane offset field. We can shift the member in the other direction by entering -15 cm. These offsets are physical, that means the analytical wire is not affected by these offset values. We can repeat the same procedure with the keyboard shortcuts. First, select the member and hit Ctrl+W on the keyboard. The member will cycle through 3 different in-plane alignment values. Similarly, by using the Ctrl+E shortcut, out-of-plane member alignment can be quickly adjusted. Ctrl+Q shortcut will rotate the member by 90 degrees angle increments. To continue with the existing member property, double-click on the member and copy the same member between trusses. To change the properties of multiple frame members, select the frame members by holding down the Control key and right-click on the member. By selecting the Edit Section/Material command, change the section profile. For example, select 80 by 80 box profile and S235 for the material quality. Then, click OK and close the window. When we select a frame member, the related commands will automatically appear on the Contextual Ribbon tab. Frequently used commands are accessible on the Contextual Ribbon tab, such as Section Angle Settings, Section/Material Settings, Splice Settings, Analysis Result Diagrams, Rotate Command, and so on. For example, if you want to assign a splice for a frame member, select Member and click the Define Splice button on the toolbar. Let's define a splice at 80 cm away from the eye end, with a width of 20 cm. Let's add vertical braces between columns. As you can see, the brace system can easily be created by using the brace command. Now, let's create a similar model by using frame members. Select the Frame command under the Modeling tab and pick the endpoints of the column and middle point of the beam. Here, the important point is to open the last member properties to continue with the same member properties. Select the frame type as vertical brace and set the angle to 0 degrees with a hinge connection. From the 3D menu, select Middle Center Alignment for the analytical wire reference. Click the Update button to apply the selected properties. We can insert another frame member using similar settings. We can also add vertical braces between trusses by using the frame member command. Let's add a frame member between the top and bottom points of the apex. Similarly, we can create an X-brace by adding another frame member between the bottom and top of the apex. If we want to divide that brace, we should add a frame member up to the middle point. Then, add another frame member between the middle point and top of the apex. We can shift the members by holding down Ctrl+E shortcuts on the keyboard. We can change the properties of multiple members at once. Select the members by boxing around or by clicking on them while holding down the Control key. We can then open the member table. We can set the properties such as frame types, end conditions, section angle from this table. Using the column-wise edit functionality available on the member table, the batch changes can be easily done for multiple members at once. Close the member table window by clicking the Close button. Now, we can create a truss model using the frame command. Firstly, draw top and bottom chords, and then using smart snap points, insert verticals and diagonals. We can set the frame type as general. Let's review and adjust the remaining frame member properties and close the window. Select the frame members you have created, right-click and select the Convert to Custom Truss command. All the selected frames will be transferred to Custom Truss Editor and frames will be automatically converted to form a custom truss. As you can see, all the truss members are initially classified as general with yellow color. Before proceeding, we need to assign proper frame types to members. Firstly, set the top and bottom chord members. Then, set other members such as diagonals and verticals. We can change the member properties on the Members tab. Especially for the larger trusses, it is much easier to change steel profiles from here. Close the window by clicking the OK button. As you can see, the frame members are turned into a single truss entity. When you double-click on the truss, the Custom Truss Editor window will launch, so you can edit the truss anytime you like. Let's insert frame members between columns. Use the polar snap points on the columns by holding down the Control key on the keyboard. These points are automatically tracked at 10 cm intervals. After selecting the first point, the second perpendicular point will be automatically recognized by ProtaStructure. In this way, a frame member is added between columns. This frame member can be categorized as a general member. The frame members which are specified as general are transferred as beam members to ProtaSteel. Let's change the profile to HEA 160A and define both end conditions as a hinge. click Update and close the window. We can use the frame members in platform-like systems for inserting vertical and horizontal braces. We can achieve the same thing by using the brace macro command, but using frame members will make our work even easier. To create brace members, run the frame command and pick the points on the screen. After creating the brace member, change the properties and set the frame type as horizontal. Select an L100x10 profile and click the Update button. We can change the angle of the frame member by typing in the value on the Properties window or the Section Manager window. Enter 90 degrees as the value for the angle. If we take a closer look at the position of the frame member, we can see that this member aligned from its middle center, so we need to assign physical offsets to locate it properly. We can set the physical offset on the 3D tab by entering a 10 cm in plane offset value. Now, let's add the same brace member between other beams. First, double-click on the brace member and add brace members accordingly. We should always consider the constructability of steel connections while modeling the steel structures. That's why frame members in ProtaStructure support extensive physical offset values. For example, double-click on the member and set the out-of-plane offset value as 10 cm. So, the endpoint of the braces is shifted 10 cm from the joints. We can similarly update other brace members. We can use the frame members to insert a buttress under cantilever beams. We can add this member by using the beam command or frame command. To do this, firstly snap any point on the column and then snap another point on the beam. This member should be named as vertical brace. We can specify all other properties of the frame member as we did before. Now, let's review the analytical model after analyzing the building. When we look at the analytical model, we can see that moment releases are assigned to the ends of the buttress member. Remember that we assigned physical offsets to brace members. Pay attention that the analytical wires of the braces extend from the beam endpoint to the column midpoint. So, physical offsets are not applied to the analysis wire. Let's check the analytical model of the truss. We can see that all the joints are assigned moment releases, and all other members that we added to the model are looking right. Now, let's switch to the Design tab to review the design results of the frame members. You can check the design of the members by clicking the Check All button. You can open and review the design summary by double-clicking on the elements. How do these members look like when transferred to ProtaSteel? We can transfer the model to ProtaSteel by clicking on the ProtaSteel button on the Designand Documentation ribbon tab. When we look at the frame members in ProtaSteel, we can see that the frame members that are assigned general frame types are transferred as beam members. Similarly, brace members that were inserted between roof truss members are also transferred as beam members. The splice defined here has been assigned to the member by dividing it. We can also see the vertical and horizontal braces and truss members. As you see, all the offset distances are transferred properly from ProtaStructure. These offsets can also be adjusted in ProtaSteel as well. However, having these adjustments in ProtaStructure provides us with even more convenience in terms of creating constructible connections in ProtaSteel. So, this summarized the usage of frame members in ProtaStructure. Thank you for listening, and do not forget to subscribe to Prota Software YouTube channel.